So let's write a Lewis structure for sulfur dioxide, SO2. So SO2, we have to put these three atoms in some sort of an arrangement. And this is where there's no direction given. Let's try to make it symmetrical. So making it symmetrical, we would put the sulfur in the middle and put the oxygen on each side. And then we need to count electrons. So oxygen and sulfur are both in group 6A. So we have 3 atoms with 16 electrons. I'm sorry, 3 atoms with 6 valence electrons, and so that gives us 18. So we need a bond here. So that's 2 and 4. 6, 8, 10, 12, 14, 16, 18. Right? 2, 4, 6, 8, 10, 12, 14, 16, 18. We don't have enough. The oxygens have octets, but the sulfur doesn't. So one of the oxygens needs to share with the sulfur. How do they decide who's going to share? Yeah, it doesn't matter. Just pick one. It's like, okay, I'm going to pick on you. You're going to share. So I'm going to take a lone pair from that guy and make it shared with the sulfur. So this oxygen has 8 valence electrons, but it's got a double bond to sulfur. The sulfur has 8 valence electrons, and the oxygen has 8. Octet rule satisfied. But what if we picked the other oxygen? So let's draw that over here. So this is what I had before. And now we're going to pick the other oxygen to share. So I'm going to take a lone pair from the one on the right and cause it to be shared with the sulfur. So in a way, these two structures are the same, right? But if you think of this as, this is Tommy and this is Michael, and they're having to share their cookies with a babysitter, do Tommy and Michael care who has to share? Yeah, they do. This oxygen is not the same atom as this. It's the same kind of element, but these are 2 different atoms, like 2 different people. And so why does one share and not the other? So these are 2 equally correct Lewis structures. And if we look at the actual molecule is neither of these. Because this would be a double bond and a single bond. This double bond should be shorter than the single bond, right? But when we examine the actual molecule, the bonds between the sulfur and oxygen are the same length. So they're kind of like a 1.5 bond. The actual molecule exists between these. It's sort of an average of those. Lewis structure doesn't handle this very well. The best we can do is to draw both possibilities and put a double-headed arrow in between it. These are called resonance structures, which implies that things are going back and forth, but that's not what's going on. So, as I mentioned, when we examine SO2, we find that both of the bonds are equivalent. They're intermediate in strength and length between a double and a single bond. They're like a 1.5 bond. It's a hybrid, an average. So let's think about dogs for a minute. Here we've got a German Shepherd. Here we've got, we'll call it a Golden Retriever. Maybe it's not a, no, that's a Labrador, isn't it? That's a white lab. That's what that is. So we've got 2 parents of different breeds, and they have puppies. And the puppies might look like this puppy here. This puppy is a combination of the 2 parents. Does this puppy look like a German Shepherd on some days and a white lab on other days? No. Does it go back and forth while you're watching? No. That would just be really, really crazy, right? So this molecule does not vacillate back and forth between these two things. It's an average, a hybrid of the two. My children are hybrids of me and my husband. I'm of Swedish descent. My husband's of Japanese descent. So our children are half Viking and half samurai. And they all look like each other. I mean, they're like, you just see one, oh, that's a Kawagoa right there. Lots of people can't tell them apart, except for the girl. Her hair's longer. She looks like her brother. But you get the idea. It's a hybrid, a combination. Okay? So we draw these two structures, we put a double-headed arrow between them, and those are called the resonance structures. We are going to find resonance structures when you need a double or a triple bond and you can't decide which atom of the same element is going to give up and share. So here we had two oxygens and we're having to pick between them. Question?
Will there ever be like 6 different structures possible?
There can be more than 2 structures possible, definitely.
Do we have to write all of them?
You may have to write all of them, yes. Yeah.
Can we just make another bond, sulfur and oxygen?
Well, how are you going to do that?
Erase it and put a bond?
So if I erase this pair of electrons and put it in here, then we're going to have too many electrons for this oxygen.
Oh, yeah, you're right.
Yeah. So, you know, Lewis theory doesn't explain how this happens. There's another theory called molecular orbital theory, which if you take Chem 1A, I'll teach you about, and that does explain how this pair of electrons that's making this into a double bond is not actually shared just between the sulfur and oxygen, it's shared over the entire molecule. But Lewis structure can't handle that. So let's write the Lewis structure for NO2 minus nitrite ion, include the resonance structures. So we're going to start out just making a skeleton here. Again, usually it's going to be symmetrical. Here we've got 1 nitrogen and 2 oxygens, so we're going to attach the oxygens to the nitrogen. And then we figure out how many electrons. Well, there's 2 oxygens, they each have 6. And there's 1 nitrogen with 5. The -1 charge says we add 1 electron. So again, we're going to get 18 valence electrons. We need some bonds. So we've got 2, 4, 6, 8, 10, 12, 14, 16, 18. So I used up all my electrons, but nitrogen doesn't have an octet. One of these oxygens has to share. The 2 atoms that can possibly share are the same element. And that says, oh, we're going to have a resonance structure here. So pick one. I'm going to pick this one. And this guy's going to share. And then I'm going to draw the same thing over here and make the other one share. I'll get to the brackets, yeah. Okay, so that's what we had come up with before we made any bonds, double bonds. So now I'm going to have this oxygen share. Just take one of its lone pairs and stick it in there. And those are the 2 resonance structures. We do need to finish it off with the brackets and the charge, because each of these has a -1 charge. And then we put a double-headed arrow, which indicates that the true structure is between that. Any questions?
How will we know
If what? Okay, love that. Okay.